Hey guys, it's time to continue our lesson on points, lines, and planes. In order to do that, we're going to start by reviewing some of the things we learned in our last video. So number one, give two other names for line AB. Here is line AB. It's got points A and B on it. It also has a label, H, with no dot by it, so that's why it's just a label. So one other name, we can just turn these letters around for a line and call it line BA. We can also name it by its label, so we can call it line H. Okay, so those are our two other names for line AB. Name 3 points that are collinear. Okay, any 2 points in the world are collinear. But if there's going to be 3 collinear points, we actually have to see the line that they are on. The only place I see a line that shows 3 points is right here. So points D, B, and C. Okay, so those are 3 collinear points. Give another name for plane F. So here it is named by its label, F. Another way to name it is with the word plane and 3 points that are not all on the same line. I could go with A, B, and E. Name a point that is not coplanar with A, B, and C. Okay, A, B, and C. So I don't actually see the plane in the picture, so we're going to have to imagine the plane that goes kind of vertical here and touches A, B, and C. Now that same plane would come down here and touch point D, but it would not touch point E. So a point not coplanar with A, B, and C is point E. Give another name for segment CD. There's only one way to rename a segment, and that is to turn it around to segment DC. 3 rays with endpoint B. So here's point B. I could name ray BC, ray BA, and ray BD. Remember, when you name a ray, you must begin with the endpoint and end with a point that it goes through, and then it goes past that point and goes on forever. A pair of opposite rays. Okay, remember they have to have the same endpoint, so we're going to use endpoint B, and they have to go exactly the opposite direction. Like ray BC goes this way forever, and ray BD goes exactly the opposite. I can't use ray BA because opposite of that, there's no point over here. H isn't a point, it's just a label. And then another name for ray CD. So to name that ray again, to use the same ray, it has to have the same endpoint, and then it has to go the same direction. So ray CD starts here, and it goes this way forever. Ray CB also starts here and goes this way forever. So ray CB and ray CD are the same ray. Okay? Now we are going to continue in our 1.1 notes where we left off in our last video. Give another name for segment EF. So that's this picture up here. When you are renaming a segment, the only way to rename it is to turn the letters around. Segment FE. Are ray HJ and JH the same ray? Okay, ray HJ starts here and goes through J. Ray JH starts here and goes through H. They're not the same ray. Okay, I know they're not the same ray because they have different endpoints. Okay, they're not opposite rays either because they have different endpoints. They do go opposite directions, but they don't have the same endpoint. How about ray HJ and ray HG? Are they the same ray? Okay, so ray HJ starts here and goes this way forever. Ray HG starts here and goes this way forever. So I would say yes, they are the same ray because they have the same endpoint and they go the same direction. So they are the same ray. Okay, and we'll move on to page 3. And we're going to do some sketching of planes. Sketch a plane, so we'll just start with a parallelogram to be our plane, and a line that is in the plane. So here's a line that is in the plane. Let's call that line AB. Okay, so we now have line AB lying inside of the plane. Okay, and let's just give this a label. We'll call it plane C. Okay, now let's talk about the intersection. Intersection, we usually think of two things crossing each other, but really it's anywhere that they touch. Line AB touches plane C all along line AB. So I could say line AB intersects plane C at line AB. So all along that line, they have points in common, so they are intersecting on that line. Okay, next, a plane and a line that does not intersect the plane. So here is a plane, let's call this plane D, and a line that does not intersect it. We'll just make it hover above, parallel to it, and we'll call this line EF. And I would say that line EF does not intersect plane D. Okay? Next sketch. A plane and a line that intersects the plane at one point. Now here we had a line that intersects a plane and it intersected all along that line. So now we want one that intersects at one point. So there's a plane. We'll call it plane G. And now I'm going to draw a line starting up here. It's going to come down to the plane, and we'll say it touches the plane right there. And what's above this plane, we can see that because from our perspective, it kind of looks like we're looking from above the plane. And then we get some hidden stuff here, and then we'll be able to see it again since our plane doesn't actually go forever. Okay, so let's call this, let's see, we're up to G, so we'll call it HI. Line HI intersects plane G at point I. Okay, next up, two planes that intersect in a line. Anytime two planes intersect each other, they intersect along a line, and I'll show you this picture here. Here are two planes intersecting each other, and the points they have in common are along this line. Okay, so we are going to draw two planes that intersect in a line. Okay, so I'm going to start by drawing my horizontal plane here. I'll draw three sides of this parallelogram to get started. Okay, so then I'm going to start by drawing three sides of the vertical parallelogram. So here's a vertical parallelogram, okay, and I'll actually draw all the way up to here. So I'll draw part of another side, okay, then I'll draw this part of this parallelogram. Okay, now I'm going to start to complete this horizontal parallelogram. I'm going to come across all the way over to that vertical one, but then it's going to be hidden. So I'm going to make it hidden until right about where this would connect with it, and then it's going to be visible again. I'll draw down from on the vertical parallelogram, and then it's going to be hidden for a little while, and there we have two intersecting planes. These take a little bit of practice to draw, so if you need to watch that a bunch of times over, go right ahead. Where do they intersect? Along this line right here. Okay, so let's call these planes J and K, and I'll put points L and M right here, and I can say that plane J and plane K intersect at line LM. Okay, and then our last sketch, two different lines that intersect a plane, but they intersect the plane at the same point. So here is a plane. Okay, so we will call that plane N, and we're going to draw a line that intersects it, and it'll intersect right there. It's hidden for a little while and then comes back out. Okay, and then let's draw another line from above to that same point, hidden for a little while, and then it comes back out. Okay, so let's call that point O, and then we'll have P and Q, and we can say that line PO and line QO intersect plane N at point O. Okay, name the intersection of line PQ and line K. So here's line PQ. Here's line K. They touch here at point M. Their intersection, all that they have in common, is point M. Name the intersection of plane A and plane B. So plane A is this lighter blue, plane B, this darker one. They intersect along this line. Anytime two planes intersect, their intersection is a line, and that happens to be line K. The intersection of line K and plane A. Okay, so where does line K and plane A, what do they have in common? So here's plane A, here's line K, and line K actually lies inside of plane A. It also happens to lie inside of plane B, but the intersection of line K and plane A, everything that they have in common is every point along line K. So we're going to finish up this set of notes with a little closer here, a little check for understanding. Are points J, K, and L collinear? If it's just 2 points, then my answer is definitely yes, but it's more than 2 points, so I have to look for them and see if the line is drawn. J, K, and L, they actually are shown to be on the same line, so yes, they are collinear. Are J, K, and L coplanar? I don't care where those points are. 3 points, any 3 points in the world are coplanar, so the answer is going to be yes. Are J, K, and M collinear? Okay, collinear, 3 points, I better check. J, K, and M, nope, they are not collinear. Are J, K, and M coplanar points? Any 3 points in the world are coplanar. Yes. Whether I see the plane drawn or not, 3 points are coplanar. The intersection of line KL and line PQ. So line KL and PQ, what they have in common is right here, point J. The intersection of line PQ and plane KMN. So plane KMN, KM and N all appear to be here in plane R. Okay, so the intersection of line PQ and plane JKM, it looks like PQ passes through that plane right here at point J. The intersection of plane R and plane S. If 2 planes intersect, the intersection is a line. Plane R and plane S intersect along this line. I can use any 2 points, M, J, or N, to name it in any order. I will call it line M, N. It could be NM, JM, MJ, JN, NJ. Name 3 pairs of opposite rays. I'll start here with point J, and from point J I can go through L or through K, and they are exactly the opposite direction. So ray JL and ray JK are opposite rays. JP, JQ, same endpoint, opposite direction. So they are opposite rays. JM and JN, same endpoint, opposite directions. Ray JM and ray JN are opposite rays.